We're working to answer the question, what angle relationships are formed when parallel lines are cut by a transversal? Now, you identified types of angles that are formed when you have two lines cut by a transversal. Next, we're going to examine and prove the relationships of angles that are formed when parallel lines, like A and B that I have here, are cut by a transversal. Let's take a look at the relationships between angle pairs. Now, when parallel lines are cut by a transversal, the angle pairs have special relationships. Here we see in the diagram I have two lines cut by a transversal, which means the classification of these angles, like I see here on the left, those are still the same. But in this case, we're talking about parallel lines. Notice the arrows on the lines. I know they're parallel because they're marked with those arrows. If they weren't marked, I shouldn't make the assumption that they are parallel. I should always trust on what's given to me as information. Let's talk about these corresponding angles first. If I take corresponding angles of two lines that are parallel cut by a transversal, then the corresponding angles, such as angle 2 and angle 6, those would be congruent to each other. Alternate interior angles. Now remember, corresponding angles, those were in the same relative location, but alternate interior angles, those are interior angles on opposite sides of the transversal, but in the different angle groupings formed by the two intersecting lines. Those alternate interior angles, such as angle 3 and angle 6, those would be considered congruent as well, given parallel lines cut by a transversal. So if I was referring to alternate exterior angles, it's the same idea. Take angle 2 and angle 7, for example. These two angles would also be considered congruent. Now, if I move on to same-side interior angles, same-side interior angles, we know those are interior angles on the same side, also called consecutive interior angles. Now, you might think that these are congruent as well, but that's not the case because it's not based on congruency. Instead, if I looked at angle 3 and angle 5, I would be able to state that their measures are supplementary. So they're going to add up to 180 degrees, just as angle 4 and angle 6 would be supplementary as well. So what I want to do now is I want to examine the proofs of the relationships of the measures of these angles. Let's start with the corresponding angles theorem. Now, if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. So looking at this diagram, I see A and B are parallel. Therefore, if they're cut by transversal C, angle 1 would have to be congruent to angle 5. Angle 2 would have to be congruent to angle 6. Angle 3 would have to be congruent to angle 7. And angle 4 would be congruent to angle 8. That's a very useful theorem. So let's go ahead and prove it. Now I'm going to prove this using transformations. Recall that a transformation is an operation on a figure that may cause it to change its orientation, its size, or its location in the plane. Now a translation, that's a type of transformation, but it preserves size and shape of the orientation as well of a figure. That's actually really useful information to us because looking over here at this diagram, we can see an intersection of line R and line Q and the four angles that are created. Now imagine I take line Q and I translate it down. So I'm going to slide it down line R, creating a parallel line. I'm going to call that line S. Now, when this happens, I'm going to end up creating four new angles at the intersection of line R and line S. So let's go ahead and write those in. I have angle 5, angle 6, angle 7, and angle 8. Now, because translation preserves shape and size, and it also preserves angle measures, then we can state that the angles located in the same place but at different intersections are in the same shape and they're the same size, and therefore they would have the same measure. Therefore 1, which kind of slid down to position for angle 5, angle 1 would be congruent to angle 5, and we could say the same for the other corresponding angles. Therefore, corresponding angles 1 and 5 are congruent, 2 and 6 are congruent, 3 and 7 are congruent, and 4 and 8 are congruent as well. So, what else can we state? Well, the opposite or the converse is true as well. So if two lines in a plane are cut by a transversal and the corresponding angles are congruent, well then their lines would be parallel. Next, we're going to examine and develop a theorem about alternate exterior angles. Let's take a look at the alternate exterior angles theorem. Now, it states that if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. So, by looking at lines Q and S, which are parallel, cut by transversal R, then this states that our alternate exterior angles, such as angle 1 and angle 8, are congruent. We can also state then that angle 2 would be congruent to angle 7. Why don't we go ahead and take a look at proving the alternate exterior angles theorem? Let's go ahead and prove that alternate exterior angles are congruent. So in order to do that, let's start with what we were given. We're given that two lines A and B are parallel to each other. So let's go ahead and mark that on our diagram with arrows. Now I'm also given that line C is a transversal of lines A and B. So line C down here is a transversal of lines A and B, forming these 8 numbered angles that I see. Okay, now in order to be able to prove our theorem, I need to pick some alternate exterior angles. So I'm picking angles 1 and 8. Now why do I know these are alternate exterior angles? Well, notice that angles 1 and 8 are on opposite sides of the transversal, a part of two different intersections, and they're outside of our two parallel lines. And because they're alternate exterior angles, if I can prove that these two angles are congruent to each other, well then I've proved that alternate exterior angles formed by two parallel lines cut by a transversal must be congruent. So let's go to our proof here. I need to start with what I'm given. I'm given that lines A and B are parallel to each other. So let's state that that's given. What else am I given? Well, I'm given that C is a transversal of A and B. Okay, well that gets me starting, but how do I prove angle 1 is congruent to angle 8? Well, what if we start with angle 1? Now I know that when two parallel lines are cut by a transversal, the resulting corresponding angles are congruent to each other. And I see that angle 1 and angle 3 are corresponding angles. So by that corresponding angles theorem, then I know that angle 1 must be congruent to angle 3. All right, well that gets me closer to angle 8, but it's not there yet. Look at angles 3 and 8. Do we know what kind of angles those are? I know they're opposite angles formed by two intersecting lines. That's right, they're vertical angles. So by the definition of vertical angles, we can state that angles 3 and 8 are vertical angles. And what do we know about vertical angles? Yes, angles 3 and 8 would have to be congruent to each other because vertical angles are congruent. So that means I can draw another arc right here. And since all three of these have the same arc, all three of these angles are congruent to each other. All right, well, what can I say then? Well, if A is congruent to B and B is congruent to C, then I know that A must be congruent to C. That's the transitive property. So if angle 1 is congruent to angle 3 by statement number 3, angle 3 is congruent to angle 8 by statement number 5, well then angle 1 must be congruent to angle 8 by that transitive property. So what did we do? Well, we proved the alternate exterior angles congruent theorem, if you want to call it that. It states that if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. Now the converse of that theorem is also true. That means that if two lines in a plane are cut by a transversal and the alternate exterior angles are congruent, well then the two lines would be parallel. Now here we have the alternate interior angles theorem. And this theorem specifically states that if a transversal intersects two parallel lines, then the resulting alternate interior angles are congruent. Here in our diagram, we see that lines X and Y are parallel because they're marked with the arrows. And since they are cut by transversal W, then the alternate interior angles that are formed, angles 4 and 5, would be congruent, and angles 3 and angles 6 would also be congruent. So now, let's go ahead and prove the alternate interior angles theorem. Here we have the same side interior angles theorem, and this states that if a transversal intersects two parallel lines, then the resulting same side interior angles are supplementary. So looking at my diagram, I can notice the same side interior angles 3 and 5. Because they are supplementary, their measures will add up to 180 degrees. We could say the same thing about angle 4 and 6. So the measure of angle 4 plus the measure of angle 6 also will add up to 180 degrees. Now let's go ahead and prove the same side interior angles theorem. We're going to prove same side interior angles are supplementary. So let's look at our diagram here. In our diagram, we see that lines B and C are parallel to each other. That information was given to us. And since it was given, why don't we go ahead and put that into our proof statement? B is parallel to C. But I'm also shown that A is a transversal of B and C. Since that's given to us, I'm going to put that in my proof as well. And I'm going to use this information to prove what? To prove that same side interior angles, also called consecutive interior angles, are supplementary. So in order to do this, let's think of other angles that might be considered supplementary. Well, looking at my diagram, take a look at angle 1 and 3. That pair, like angles 2 and 4, I see are adjacent angles that form a straight line, and that tells me they are a linear pair. I know this because the definition of a linear pair tells me. Well, if that's the case, then I can actually use the linear pair postulate. Remember what it tells you? The linear pair postulate says that if two angles form a linear pair, then I know they're supplementary. All right, well, I've got some supplementary statements going on here, but what do I know about supplementary angles? Well, going back to my glossary, if I were to actually look up the definition of supplementary angles in the glossary, it tells me that I have the measures of the two angles would add up to 180 degrees. So now I've actually got some equations to work with. But notice that two of the angles in this equation are interior, angles 3 and 4, but measure of angle 1 and measure of angle 2, I'm talking about angles outside. All right, well, if that's the case, then I need to do something with angles 5 and 6. Well, looking at angle 1 and 2, notice how they form corresponding angles with 5 and 6, respectively. Angle 1 and angle 5 are corresponding angles, and since I've already stated that line B and line C are parallel, then I know that those angles must be congruent to each other because of the corresponding angles theorem tells me. So angle 1 would have to be congruent to angle 5, and angle 2 would have to be congruent to angle 6. All right, well, if two angles are congruent to each other, that means their measures are equal. We know this because of the definition of congruent angles. All right, so if their measures are equal, I can go back and look at step 5 and see, hey, wait a minute. I bet I could substitute out my outside angles and bring in my interior angles. So let's use substitution property and replace the measure of angle 1 with the measure of angle 5, and we'll replace the measure of angle 2 with the measure of angle 6. So now I have the measure of angle 5 plus the measure of angle 3 is equal to 180 degrees, and the measure of angle 6 plus the measure of angle 4 is equal to 180 degrees. And since we have two angles that add up to 180 degrees, what do we know about them? We know they are supplementary. Once again, that same definition of supplementary angles helps us out. So I've now proven that same side interior angles are supplementary. In fact, we can also state based on this that same side exterior angles would be supplementary as well. But what's the official proof saying? Well, our theorem that we've now proven, it states that if two lines that are parallel are cut by a transversal, then the same side interior angles that are formed will be supplementary. The converse is also true. The converse tells us that if two lines in a plane are cut by a transversal, such that the same side interior angles are supplementary, well, then we know the original two lines in the plane that were intersected, those would be parallel. We've been working to answer the question, what angle relationships are formed when parallel lines are cut by a transversal? Now, in this last part, we worked to study proofs and theorems about the relationships of angles formed when two parallel lines are cut by a transversal. And the relationships are shown here in the table in front of us. And what we're going to do is we're going to use these theorems and these proofs in order to be able to help us solve for unknown angle measures in this next part.
fun? Applying angle pair relationships to find unknown angle measures. I know, right? We can analyze this drawing and use the given angle measure to find other measures. Oh, here's a 100-degree angle along transversal D. That's going to be important. We see that D is a transversal of lines E and F. Also, we see E and F are parallel to each other. That means the 100-degree angle and angle 15 are alternate exterior angles. And the alternate exterior angles theorem tells us that angle 15 would have to be 100 degrees also. And because angles 15 and 14 are vertical angles, and vertical angles are congruent, angle 14 is 100 degrees as well. Angle 11 and the original 100-degree angle are vertical angles. So, angle 11 is 100 degrees also. Now, take a look at the remaining angles on that transversal. Angles 9, 12, 13, and 16. And they each form a linear pair with one of the 100-degree angles I've identified. Linear pairs of angles are supplementary and sum up to 180 degrees. We can subtract 100 degrees from 180 degrees, which gives us 80 degrees. Therefore, angle 9, angle 12, angle 13, and angle 16 all have a measure of 80 degrees. What about the measures along transversal C? Well, we can't find them. Why not? Because we need at least one given angle measure along its transversal C in order to be able to use the theorems to find them. If C had been parallel to D, we certainly would have been able to.
So let's take a look at another problem where we can apply angle pair relationships. And this time for our diagram, we're going to identify the measure of angle 3. And we want to justify our answer, which means we want to make sure we give a really good reason of why that answer must be correct. Now, if I take a look at my diagram, I see I have lines S and T parallel to each other. Notice the markings of the arrows. And so I see that R is a transversal. And because that transversal cuts the lines in such a way that this angle, x plus 10 degrees, and 2x minus 30 degrees are both alternate exterior angles, then I know based on the alternate exterior angles theorem, they must be congruent. Therefore, they have the same measure. So I can take that x plus 10 and I can set it equal to the 2x minus 30. Well, let's use this information to help solve for x and find out what is the measure of that angle. All right, well, I can subtract x from both sides using the subtraction property of equality, and I can also add 30 to both sides using the addition property of equality, and I'm going to get an x value equal to 40. So with that 40, I can substitute it back in for x. I'm going to get 40 plus 10, which gives me 50 degrees over here on the left. And if I plug 40 in over here, well, 2 times 40 is 80, and 80 minus 30 is 50. So that gives me 50 degrees on this side as well. This is important because it justified that my work was correct. Well, now that I have a 50-degree angle on the left and a 50-degree angle on the right, how can I use it? Well, I see that angle 3 here and this 2x minus 30, they both are corresponding angles. And since their corresponding angles are congruent when two parallel lines are cut by a transversal, I know that their measures must be the same. So I know angle 3 must be 50 degrees. Now notice this was just one way to be able to solve this particular problem. For example, I could have taken this 50-degree angle that I found here, realized, hey, it makes a vertical angle with angle 3. So therefore, angle 3 must have 50 degrees measured as well.